This is Algebra 2, Unit 6, Lesson 1 and Factoring Review. In this unit, we are going to be doing a lot of factoring because we're going to be dealing with quadratics. So, let's review the kinds of factoring that we learned back in Algebra 1. You should be expert at this by now. Alright, the kinds of factoring that we've done before. First one is factoring by GCF, or reverse distributive. You take out the highest, greatest common factor that you can find, and then divide it out, and then write it as a product. So, 6x plus 15. Your GCF will be 3. Divided out, 6x divided by 3 is 2x. 15 divided by 3 is 5. So it looks like the distributive law when you're done. You could always remultiply to see if it's the same. 3 times 2x is 6x. 3 times 5 is 15. Now, remember when you're doing a GCF can be a number, a variable, or a number and a variable both. So 50x minus 5x squared, what's your GCF? Well, number-wise, we can take out a 5 on both of these, and we can also divide out an x. So your GCF is actually going to be 5x. When I divide out the 5x, 20x divided by 5x is 4. 5x squared divided by 5x is minus x. 5x times 4 minus x is the factored form of 20x minus 5x squared. All right, 8x cubed minus 12x squared plus 20x. What's your GCF? Numerically, it's going to be 4. And with the variable, your highest power of x is going to be x, that you can take at least one x out of each one of these. Dividing it out, you're left with 2x squared minus 3x plus 5. And there we go. That's reverse distributive. Our second kind of factoring we have is the difference of squares. This is a special kind of factoring because both the a and the b value are perfect squares, and there's a minus in the middle. The nice thing about this, you end up with factors of a plus b times a minus b. Notice here that these factors are the same except for the sign. One is plus and one is minus. These are also called conjugate pairs. When you have exactly the same factors except for the plus and the minus, they are called conjugate pairs. And the special thing about them is when you do the outside-inside term and you FOIL them, it comes out to be 0. That's why this only has 2 terms. It is 2 perfect squares with a minus in the middle. So, if we have x squared minus 9, x squared is a perfect square, 9 is a perfect square, there's a minus in the middle, this is going to factor by difference of squares. So it's going to be x plus and x minus, the square root of 9 is 3. Very simple. 16 minus 81x squared, 16 is a perfect square, 81x squared is a perfect square. Double bubbles. Square root of 16 is 4, so 4 times 4 is 16 goes here, plus and minus. And what gives me 81x squared perfect squares? 9x and 9x. So 4 plus 9x and 4 minus 9x. Now notice the order on this. The x is at the other end because notice the x has to be negative. Make sure you put it in the order that you want. If you want the number first here, it has to be factored first here in your terms. And the x squared has to be on the other end. Alright, now don't let the fractions throw you. 4 81's x squared minus 49 9's. All of the numbers, 4, 81, x squared, 49, and 9 are all perfect squares. All you have to do, when you split them up, is take the square root of each part. So, make my fraction bar here, fraction bar here. How do I get a 4? Well, that's going to be a 2 and a 2. How do I get 81? 9 and 9. How do I get x squared? X and x. There's my first term. Done. Plus and minus. How do I get 49? Be 7. That's in the numerator. 7's also in the numerator there. How do I get 9? 3 and 3. So as long as they're all perfect squares, it doesn't matter if they're fractions or not. You can still factor them. All right, what about 4x squared plus 25? Well, this one actually is a trick question. 4x squared is a perfect square. 25 is a perfect square, but there's a plus in the middle. This is not a difference of squares. It is a sum of squares. So that means this does not factor. At least not by difference of squares it doesn't. So this does not factor. We cannot factor this anymore. This is 4x squared plus 25 is 4x squared plus 25. And that's all you can do. So For difference of squares, you're looking for a two-term polynomial. Both of the terms are perfect squares, and there is a minus in the middle, and then you can apply the conjugate pairs, a squared minus b squared equals a plus ba minus b. And our third kind of factoring is reverse FOIL. Reverse FOIL, you have a trinomial in descending order, highest exponent first, and you want factors in double bubbles, like so. All right, we know the first term for this one is going to be x times x. For the signs, the last term is positive and the middle term is positive, so this is going to be plus plus. And then we need the factors of 24 that add up to 11. Well, the factors of 24 are 1 and 24, 2 and 12, 3 and 8, and 4 and 6. Which one of these has a sum of 11? Well, it would be 3 and 8. So x plus 3, x plus 8. Very simple. We've been doing these since Algebra 1, so you should be very good at them. X squared minus 13x plus 22. All right. Factor, factor, factor. We know x and x. What kind of signs does this have? On this one, the last term is positive, but the middle term is negative. So to get a positive product, you either have to have plus, plus, or minus, minus. Well, to get a minus in the middle, it would have to be minus, minus. So this would be minus and minus. All right, and the factors of 22. Well, that would probably be 2 and 11. 2 and 11 minus 2x minus 11x gives you minus 13x. And it works. There we go. All right, x squared minus 5x minus 50. Double bubbles. X and x. All right, now since this time the factors of 50 are negative 50, you want it to be plus and minus. We don't know where they're going to go yet. So plus and minus I'll put in. Now I need the factors of 50 that add up to negative 5, with one being plus and one being minus. Well, that's probably going to be 10 and 5. All right, so if I want it to be 10 times 5 to be 50, but I want it to be negative 5, it would have to be negative 10 and positive 5 to get negative 50 multiplied, but added to be negative 5. So negative 10 would have to go here, positive 5 would have to go here. All right, now what if your leading coefficient here is bigger than 1? Well, that doesn't matter, it's still factors. You have to fill in as much as you possibly can. How do you get 3x squared? Well, the only way to get 3x squared is 3x times x. So we know the first term would have to be 3x times x. All right, now sign-wise, this is negative 40, so it's going to be plus and minus. All right, but I'm not going to put it in yet until I know where my numbers are going to go. All right, my options for 40, I have 1 times 40, 2 times 20, 4 times 10, and 5 times 8. That gives me 40. Now remember, whatever one goes here on the end term is going to be multiplied by 3x when we do this. So 3x times something plus this will give me positive 19. Well, if I do 3 times 8 is 24, and 5, make one of those negative, I'd be all set. Well, let's see, this would be 24x, this would be 5x. If I do positive 24 and minus 5, that'll give me 19x. So if I want this positive 24, this would have to be plus 8, this would have to be minus 5. And we've got it. 3x minus 5, x plus 8. All right, so you just have to be considerate of your options when you do these. 10x squared plus 13x minus 30. There's no GCF there. So all I can do is my options for 10x squared. I can either use 10x times x or 5x times 2x. For 30, I can use 1 times 30, 2 times 15, 3 times 10, or 5 times 6. So I have to use some combination of each of these to get this to work. Well, let's do a little thinking here. If I use 10 and x, I'm going to be multiplying one of these terms by 10, and that's going to be a pretty big number, isn't it? So probably 10x isn't going to work. It might, but I don't think so. So let's try 5x and 2x. If you're not sure, plug some in and see if they work. That's all you can do. All right, so we want to make sure the outside-inside work. If we want this to add up to 13, whatever goes here is going to be multiplied by 5. Whatever goes here is going to be multiplied by 2. And we want it to add up to 30 with different signs. All right, so probably 1 and 30, those are fairly big numbers. That's probably not going to work. Same thing with 2 and 15. Probably let's try the smaller numbers. Now, would it make sense to put the 5 over here? Well, not really, because that would give me a GCF over here, and that wouldn't work. This problem doesn't have a GCF, so our factors can't have GCFs either. So why don't I put the 6 there and the 5 there? That gives me 12x and 25x. Now remember, this is negative, so the signs are going to have to be different. So to get positive 13, it would have to be plus 25 minus 12. So the plus would have to go on the 5, the minus would have to go on the 6. And it works. And that gives me 13x. All right, one more. 36x squared minus 35x plus 6. All right, let's see. For 36, we have 36x times x. We have 2x times 18x. We have 3x times 12x. We have 4x times 9x. And 6x times 6x. And then for 6, we have 1 and 6, and 2 and 3. Okay, so let's see if we can figure this one out. All right, sign-wise, what kind of signs is this going to have? Well, if it's plus on the end but minus in the middle, it's going to be minus minus. So we want whatever factors we pick to be multiplied by these other factors to get to be 36. All right, see if you can do that one and figure out what the value is. We'll go over that in class the next day. It's also important, once we've reviewed the types of factoring, to be able to factor completely, which means basically factor until you can't factor anymore. You want to combine the types of factoring until all factors are prime, until they can't be factored anymore. So the first thing you always want to look for is a GCF. If there is one, factor it out. And then check your remaining factors to see if difference of squares or reverse FOIL apply. So let's take a look at this. 4x squared plus 12x minus 40. All right, does that have a GCF? Yes, it does. The GCF in this particular one is going to be 4. So if I GCF out the 4, I am left with x squared plus 3x minus 10. Well, 4 is completely factored. X squared plus 3x minus 10 is a trinomial. It's probably reverse FOIL. Let's see if it is. X, plus and minus. Factors of 10 that give me 3 would be positive 5 and minus 2. Now, x plus 5 is completely factored. X minus 2 is completely factored. 4 is factored. That's completely done. Now, if we wanted to, we could remultiply this, and we'd get the same thing back. So that's completely factored. All right. 6x squared minus 24. Do I have a GCF? Yes, my GCF is 6. 6x squared minus 24, factor out the x, is x squared minus 4. And then x squared minus 4 is difference of squares. And that's going to factor as x plus 2, x minus 2. And there we go. Recognize the pattern. 2x squared plus 20x plus 50. GCF is 2. X squared plus 10x plus 25. All right, so trinomial, probably reverse FOIL, double bubbles, x and x, both positives. Factors of 25 that give me 10 would be 5 and 5. All right, so make sure you take the GCF out first, and then worry about difference of squares or reverse FOIL. 75 minus 3x squared. All right, GCF would be 3. If I factor out the 3, I'm left with 25 minus x squared. All right, now, is this difference of squares? Yes, it is, but notice here the x is on the other end. That doesn't matter. When you factor it, you have to know where it goes. So your first term on here isn't going to be x and x, it's going to be 5 and 5. Plus and minus, and then x and x. There we go. Okay, 10x squared plus 55x minus 105, GCF is 5, which is going to give me 2x squared plus 11x plus 21. Factor, or minus 21, I'm sorry. This is going to double bubble, but instead of having x and x, what are we going to have? We're going to have 2x and x. Factors of 21, probably 7 and 3, but what one's going to be multiplied by 2 would be the 7. So that gives me, I want plus 11, so that's going to be positive 14, minus 3, and completely factored. Okay, so try this one yourself, see what you come up with for a GCF and factor it out. And then we'll do the last bunch together in class the next day.